Linear functions. In this lesson, we're going to talk about the basic concepts of linear functions. We'll talk about the standard form for linear function. We'll talk about slope and interpret slope as an average rate of change, and also look at linear models. Okay, so a linear function is of the form f of x equals ax plus b. A and b are real numbers, and if a is not equal to 0, then the domain and range are both all real numbers. Okay, so if we're asked to graph a linear function using intercepts, we simply find the x and y intercepts. So the x-intercept occurs where y is 0, so we just let y be 0. So y is f of x, so we have 0 equals negative 2x plus 6. Solving, we'll have negative 2x is negative 6. That makes x 3. So here I have 3, 0. Next, I'll find the y-intercept. So the y-intercept is found by letting x be 0. So letting x be 0, we have y equals negative 2 times 0 plus 6, which is 6. So our ordered pair is 0, 6. All we need to do now in the rectangular coordinate system is plot those 2 points and connect with a smooth line. So here's 3, 0 and 0, 6. Okay, connect those, and we have the linear function graphed. Next example, we're going to graph a horizontal line. Whenever you have a graph function of the form f of x equals some number, y equals some number, you know you have a horizontal line. Okay, so here y equals negative 3. To graph it, we simply go to our y-axis, we find negative 3, and we just draw a horizontal line through that. So again, y equals some number is a horizontal line. Okay, vertical lines are x equals some number. So if you have x equals some number, you're thinking, okay, then that relation is a vertical line. And so what we do here is in our rectangular coordinate system, we just find x is negative 3, and we draw a vertical line through that. Okay, let's go back now and talk about domain and range for all of those problems that we just graphed. So for the first one, the domain and range is all real numbers. For the second function that we graphed, we have the domain is all real numbers because x can take on any real number. All right, and then the range, because y is negative 3 and can't be anything else, we write our range as a single element in set notation. Okay, with the relation x equals negative 3, our domain would include just the single value, x can only be negative 3, and the y value can take on any real number value, negative infinity to infinity. Okay, standard form for a linear function is ax plus by equals c. We do have some restrictions here. A has to be greater than or equal to 0. A, b, and c all have to be integers, okay, and their greatest common factor has to be 1. So let's look at an example. So let's say we're asked to graph 4x minus 5y equals 0 and name the domain and range. So when c is 0, we have a line that goes through the origin. So if we let x equal 0, we have 4 times 0 minus 5y equals 0. That gives us negative 5y is 0. Divide both sides by negative 5, and you can see here that the point 0, 0 is on the graph. That is the origin. We will need a second point to plot on the graph. You can choose any value for x or y, and then solve for the other. So here, I'm going to let x be 2. So 4 times 2 minus 5y is 0. 8 minus 5y is 0. Subtract 8 to the right. Okay. Divide both sides by negative 5. That means that y is 8/5. Okay, and so now we're just going to graph in the rectangular coordinate system this line that goes through the origin, 0, 0. And another point on the graph is 2, 8/5. Okay, and then 8/5 is going to be, let's see, a little bit less than 2 there, so we'll get right here. Okay, this was 2, 8/5. There we go. So we have our line graphed. Okay, now let's switch gears a little bit and talk about slope. Slope measures the steepness of a line and its orientation. So where is it in the rectangular coordinate system? We interpret that as rise over run. The horizontal distance is x2 minus x1, denoted as delta x. And the vertical distance y2 minus y1 is denoted as delta y. So written all together in symbols, the slope is defined by m. Okay, we use m to denote slope. If we have 2 points, x1, y1, we find the slope by just taking the difference in the y's all over the difference in the x's. Okay, the slope of a vertical line is undefined. Okay, that's due to a 0 in the denominator. We'll learn in a moment that the slope of a horizontal line is 0. Okay, so we want to find the slope of the line that goes through these given points. So we have the slope is y2 minus y1 all over x2 minus x1. So we need to label those points, x1, y1, x2, y2, and then we simply plug in to our formula. So negative 3 minus 8 all over 2 minus a negative 4. We do need to be careful with our signs, right? In the denominator, 2 negatives will make a positive, so our final answer for slope would be negative 11 over 6. Next, if we find the slope of the line through these points, notice that x is 2, right? When x is 2, we know we have a vertical line. If we were to plot those points, we could confirm that, okay? And we know by fact that the slope of a vertical line is undefined. All right, when the y values repeat, okay, we know we have a horizontal line, okay? And a horizontal line has a slope of 0. So the slope of a horizontal line is 0. We can verify that by plugging in. So if we label our points x1, y1, x2, y2, and we calculate the slope, we'll get negative 3 minus a negative 3, right? All over negative 2 minus 5. And so we find there that in the numerator, we get a 0. And so numerically, it works out. But again, once you see that these y values repeat, there's no need to really calculate the slope. You simply note that the slope of the horizontal line is 0. Okay? Okay, next, if we're asked to find the slope of a line, we can write it in what we call slope-intercept form. Slope-intercept form you may be familiar with. It's y equals mx plus b. Okay, again, that's called the slope-intercept form for the equation of a line. So what we're going to do is we're going to take this equation right here, and we're going to solve that for y, so that we can determine what m is, okay? So we're going to solve 4x plus 3y equals 12 for y. Okay. So we are going to subtract the 4x to the right. So we get 3y equals negative 4x plus 12. Dividing every term by 3, right? We have y equals negative 4/3 x plus 4. Okay. We said a moment ago that the m is what sits in front of x, right? So the coefficient of that linear term. So if we want to find the slope of the line, it is negative 4/3. Okay, next we want to talk about how to graph a line that passes through a particular point and has a slope. Okay, so if the point is negative 1,5 and the slope is negative 5/3, we can simply plot the point and count the change in y over the change in x. And so you can see here that we have plotted negative 1,5, and by just going down 5 and to the right 2, we locate that second point, which then results in a line when we connect them. In summary, these are some facts that we've discussed about slope. All right, a line with a positive slope rises from left to right. A line with a negative slope falls from left to right. A slope of 0 is true for a constant function. Okay, y equals some number. And then the slope of a vertical line is undefined. All right, so we can interpret the slope as meaning the average rate of change. So that is given by this formula here, f of b minus, and that should be f of a, so it's a typo, f of b minus f of a all over b minus a. So that's the difference in the y's all over the difference in the x's. Okay, because you have an ordered pair like a comma f of a, b comma f of b, and then here we just take the difference in our y's in our slope formula all over the difference in our x values. So pretty straightforward there, and we call that the difference quotient. Okay, so here we have an example with average rate of change. So we have in 2009, Google spent $2,800 million on research and development. In 2013, Google spent $8,000 million in research and development. We want to assume a linear relationship and find the average rate of change. So to do that, we're going to write down our ordered pairs. 2009 corresponds with 2,800. 2013 with 8,000. And then we just find that average rate of change. So this is a comma f of a, b comma f of b, and now we just pull or plug into our equation. So our slope is the average rate of change. Okay. The average rate of change is going to be f of b minus f of a all over b minus a. So it's going to be 8,000 minus 2,800 divided by 2013 divided by 2009. So that arithmetic, let me do that real quick and we'll figure out what that is. Okay, so we have 8,000 minus 2,800. Then we're going to divide that by that difference, which is 4, and we get 1,300. So $1,300 million would be our average rate of change per year. Okay, and then finally we're going to talk about the linear cost model. So if you want to model cost, you would use this equation. So instead of y equals mx plus b, we have c of x equals mx plus b. Okay, m is our variable cost, and b represents our fixed cost. Okay, and so we also have the concept of revenue associated there with linear models. So our revenue is just the price per item times the number of items we sell. The profit is simply the difference in what we bring in and the amount that goes out, the amount that it costs. Looking at an example here, we assume that the cost to produce an item is linear, right? A fixed cost is $1,500 and variable cost is $100. The item sells for $125, okay? So if we want to write linear functions to model cost, revenue, and profit, we would use those formulas that we just learned about, okay? So C of X equals, right? We have M, which is our variable cost, times X, plus our fixed cost. So that's our cost function. And then we have our revenue function as our R of X. R of X is simply X times P. So the price per item is $125, so we have 125X. All right, and then finally, our profit, our P of X, is just R of X minus C of X. So we'll just combine like terms there. So we have P of X equals 25X minus 1,500. All right, so that's the answer to part A. Part B, okay, for part B, we want to know how many items do we have to sell to make a profit. So our profit function is given by, let's see, P of X is 25X minus 1,500. So we want this quantity to be non-negative. That means we would have a profit. So we're simply going to set our 25X minus 1,500 greater than or equal to 0 and solve that. So we have 25X is greater than or equal to 1,500. Divide both sides by 25, and let's see what we come up with there. We come up with 60. So that means we have to sell at least 60 items in order to make a profit.